Hey everyone, welcome back. Today we're diving into something that I think a lot of us can relate to. It's an article from Academy about, get this, the biggest mistake junior engineers make.
Oh, yeah, I've seen this one.
And surprisingly, it's not about, writing buggy code or anything like that.
It's a way more fundamental than that and trips up so many new devs.
So what is it? What's this big mistake?
Basically, it's jumping into solving a problem without actually, really understanding the problem first.
Oh, okay, yeah.
Just rushing to get to the solution.
Yeah, like trying to bake a cake without actually looking at the recipe. You just throw some stuff together and hope for the best.
Exactly. And you end up with something, but probably not the cake you were hoping for.
Yeah, definitely not going to win any baking competitions that way. But seriously, why do you think so many junior engineers fall into this trap?
Well, picture this, right? You're fresh out of that coding boot camp, you're feeling good, you land your first coding gig.
You're ready to take on the world.
Exactly. You're excited, you want to impress everyone, and I think naturally you just want to prove that you have the skills.
Yeah.
And so it makes sense to want to jump in and just get going.
Right, prove yourself.
Yeah, but that enthusiasm can backfire if you're not careful.
Makes sense, yeah. Is that feeling of, when you're trying to impress someone on the first day at a new job, and you're so eager to please that maybe you don't ask all the clarifying questions that you should.
100%. And then the tech industry, it's fast-paced, there are deadlines.
It's go, go, go.
All of that just adds to this temptation to dive straight into the code without, actually planning and thinking things through.
Yeah, so it's not just about being the fastest coder, right? It's about being the smartest.
Exactly. It's about strategy. It's about thinking like a problem solver. Mm-hmm. And the article, it actually outlines a few reasons why this rush to solve thing is so common.
Oh, okay. I'm curious.
Well, like we were talking about, that pressure to perform in a new role is huge.
It's huge. Trying to wow everyone with your coding skills.
And it can be really intimidating to ask for help.
Oh, absolutely.
Like you said, you don't want to seem like you don't know what you're doing.
Especially as a junior engineer.
Right. But honestly, asking questions, it shows that you're thinking critically, that you want to get it right.
Yeah, for sure. It shows you care, that you're not just blindly following instructions.
Exactly. You're engaged. And then there's overconfidence, which, coming out of a boot camp, it's easy to feel like you can code anything.
You've got all the skills.
Right. But a little humility can go a long way.
Absolutely, yeah.
Even seasoned devs, we get stumped sometimes.
Yeah.
Every problem is an opportunity to learn something.
100%. I think that's a really good point because it's easy to, I think, especially in this industry, to get caught up in, feeling like you need to know everything.
Right.
But it's constantly evolving.
It is.
There are always new things to learn.
Exactly. And that's why having a structured approach, being methodical, is so important for long-term success.
So it's like building a house. You don't just start laying bricks without a blueprint.
Exactly. You need that solid foundation. And in coding, that foundation is really understanding the problem.
Totally. And Academy, they talk about something called algorithmic thinking to help with this.
Yeah, that's a big one.
So for anyone who, like me, needs a little refresher, what exactly is algorithmic thinking?
Okay, so think of it like, and this might sound a little weird, but think of it like making a pasta sauce.
Okay, I like where this is going.
You wouldn't just throw all the ingredients in the pot all at once, right?
Yeah.
You've got your steps.
Yeah.
You chop the veggies, you saute them, you let it simmer. Algorithmic thinking is similar, except instead of food, you're creating code.
So it's about breaking down those complex problems into smaller, more manageable steps, like a recipe for code.
Exactly, and you're defining those steps logically so that the computer can understand and execute them.
Right, so it's not just about code that works, it's about code that works well.
Yes. Elegant code, efficient code.
And Academy, they have resources to help with this kind of thinking.
Yeah, they've got interactive tutorials, coding challenges, all sorts of things to get those problem-solving skills sharp.
That's awesome. It's like having a coding mentor right there with you.
Right. And they even have this really cool AI-powered coding assistant.
Oh, AI. Tell me more about that. I want to hear about this.
So imagine this, right? You're working on a challenge and you get stuck. Instead of just giving you the answer, this AI assistant, it's like it nudges you in the right direction,
Oh, interesting.
Yeah, it asks you questions, it gives you hints. It's like having a coding buddy there with you.
It's like having a more helpful Clippy. Remember that.
Right, exactly. But way more helpful and actually relevant to the code you're writing.
Okay, that is cool. I like it. So it's not about making it easy. It's about teaching you how to think through those problems.
Exactly. And that actually leads perfectly into those 5 key takeaways from the Academy article.
Okay, yes. The 5 takeaways for avoiding this rush to solve trap.
Yeah, they're like golden rules for becoming a better programmer.
All right, let's hear them. What's number 1?
Number 1 is all about embracing the planning phase.
Okay, planning.
It's like that measure twice, cut once saying about it, but for code.
I get it.
So before even opening up your code editor.
Before you even think about writing a line of code.
Exactly. Take that time to really, truly understand the problem you're trying to solve.
So no more just diving headfirst into the code.
Nope. Think of it like planning a road trip.
Okay, I like this analogy.
You wouldn't just start driving without knowing where you're going. You've got to map it out, right?
Exactly. You need your route. You need to know where you're stopping for snacks, all the important stuff.
Right. And with coding, you need to figure out your destination. And Algo Academy, they suggest using pseudocode.
Pseudocode, yeah.
It's like a simplified version of your code, but written in plain English.
Oh, I see. So you're basically outlining the logic before you get into the nitty-gritty of the actual code.
Exactly. It helps break down those complex steps. Plus, it makes it easier to spot any potential issues early on.
So much better to catch those roadblocks before you've already written a ton of code.
100%. And this actually segues into our next takeaway, ask questions.
Yes. Don't be afraid to ask.
So many junior devs, they're hesitant to ask for clarification because they don't want to seem inexperienced.
I totally get that. But you've got to get over that fear.
You do. Asking thoughtful questions, it shows you're engaged, that you're really trying to understand.
It shows you care. And it can save you so much time and frustration later on.
Exactly. The article even gives some good examples of questions to ask, like, let's say you're building a feature to sort customer data.
Okay, yeah, I'm picturing it.
You should ask things like, how should we sort it? Alphabetically? Chronologically? What if there are duplicate entries? Those are things you need to know.
Right. Like what happens in this weird edge case? Those are good questions to ask.
Exactly. It's about thinking critically and considering all those different angles.
Okay, so we're planning, we're asking questions. What's next? What's takeaway number 3?
This one is big. Start with test cases.
Okay, testing. I'll admit, testing is something I'm still a little fuzzy on.
Yeah, it can seem a bit mysterious.
It does. So, like, for someone who maybe hasn't quite wrapped their head around testing, what are test cases and why are they so important?
Think of them as a safety net for your code. Like imagine building a bridge, right?
Okay, yeah, big bridge.
You wouldn't just assume it's strong enough to hold tons of cars, right? You'd test it.
Right, stress test. Make sure it's not going to collapse.
Exactly. And test cases are basically those tests, but for your code. You're making sure it can handle different scenarios and inputs.
Oh, I see. So it's like, instead of just hoping for the best, you're actively trying to break your code before someone else does.
Exactly. And here's the key thing. You actually write these test cases before you even write the code that will make them pass.
Wait, so you're creating tests for code that doesn't even exist yet?
You got it. Sounds weird, but it forces you to think through all those possibilities, even the weird ones.
That's actually really smart. So you're not just thinking about the happy path, you're thinking about all the weird, roundabout ways someone might use your code.
Exactly. You're considering those edge cases.
Those edge cases. I've heard that term thrown around. Okay, so I'm assuming Algo Academy has some thoughts on how to make this testing thing easier.
They do. They have tools, frameworks, all sorts of things to help you write and manage your test cases.
That makes sense. It seems like a very specific skill set.
Yeah, it's important. And they even have features that help you find and handle those tricky edge cases.
Nice. So they're not just telling you to test, they're giving you the tools to actually do it effectively.
Exactly. They've got you covered.
I like it. Okay, so we've planned our approach, asked a bunch of questions, we've got our safety net of test cases in place. What's next? Time to actually start building. Right.
Yes. Takeaway number 4. Implement incrementally.
Okay, incrementally. What does that mean? Like build it in stages.
Exactly. Think of it like building something out of Lego.
Okay, I'm with you. I love Lego.
You wouldn't try to put all the pieces together at once, right? You build in sections.
You start with the base plate. All right, I'm totally getting this analogy.
Right. And with code, it's the same idea. Break down that massive project into smaller, manageable chunks.
So it's less overwhelming, and you can actually make sure each part is working before you move on.
Exactly. You're testing as you go, catching errors early on.
So you don't get to the end and realize you have to tear the whole thing down and start over.
Exactly. Plus, it lets you show your progress, get feedback along the way.
Right, which is especially helpful when you're a junior dev and you want to show that you're making progress.
Absolutely. And